Hi folks, as always, thank you for joining me on this video. Today we are going to I'm going to reintroduce what composite function is, and then we will eventually get into the chain rule. So this is going to be a series of 3 videos. Okay, so this first one we're just going to talk about composite functions. Okay, so many functions are the composition of 2 or more functions. Let's go ahead and pick us a color. I'm going with orange today because it's in October. Alright, so many functions are the composition of 2 or more functions. So sometimes you'll get something like y equals sine 5x, where you actually have 2 functions. You have sine x, which is the outside function, okay, outer, and then 5x, which is the inside function, or we'll call it the inner function. Okay? So the composition f of g of x, the way we write it sometimes is f of g of x. And this is more friendly to me. I think this way. So whenever I get a question that says f open dot g of x, that just tells me to rewrite it. Okay, so I like to rewrite it like this. So anyway, where f is the outer and g is the inner function. So when computing values from a table, work with the inside function first. Now you'll find that derivatives are going to be opposite this, but when we're actually just going to compute a value on a table, you work inside to outside. So let me walk you guys through that. That is not the button I wanted to push. Okay, there we go. Here's a table, and across the top are the x values, and each row represents the function values at those x values. So for example, f of 1 equals 3. Okay, so this is how you're supposed to interpret this table. Okay, and there are a couple of examples there too. So on this one we have g of f of 1. So I'm going to underline f of 1 twice. Okay, so this is going to be g of some number. Alright, f of 1, well, we already said that f of 1 is 3. Okay, so that number I'm underlining twice as well because f of 1 turned into 3. Okay, now we need to find g of 3, and g of 3 is 6. Alright, so that's how we approach these problems. Inside to outside. So the inside function, or the inner function, looks like f of 4. F of 4 is 2. So I need to do f of 2. See, this 2 represents f of 4. Okay? But now I just need to compute f of 2. So go up to 2. F of 2 is 5. Okay? The next problem, it says g of 1. So f prime of g of 1. G of 1 is 5. So basically I just need to find f prime at 5. F prime at 5 is -4. So I'm hoping that that is enough examples for you to pause the video and try these next 2. But notice that these next 2 are a little bit different. See, this 2 is saying to square the inner function, but this squared, this 2 out here, is saying to square the outer function. After you've already computed everything, then square it. Okay? So there is a small difference there, so let's go walk through that. Number 4 says g prime f of 4 squared. So we're going to do g prime of f of 4. That's what we need to do on the inside. So f of 4. F of 4, it looks like, is 2. So g prime of 2, but remember that 2 is being squared. So I need to square it now, so this is g prime of 4. And g prime at 4 is 1. Okay? Alright, the next problem we're going to work inside and get f of 4. So, well, we've already computed f of 4 before. F of 4 is actually just 2. So this is actually going to be g prime of 2. Okay, that 2 went in. But the whole thing is supposed to be squared. So again, we're working inside to outside. So inside function is just g prime 2. G prime at 2 is 4. So now I have 4, and then that 4 is actually just going to get squared, right? So 16. All right. So that is how you use a table, and that's how you actually evaluate a composition of functions. So that's our first video. If you want to continue learning about derivatives, you'll have to follow up and watch the next couple of videos. All right? Take care.